Guys, so now we'll be moving on to talking about t-tests. There's several different kinds of t-tests, so we're going to break it up into a couple different sections. And we're going to start with what we call t-tests with independent samples or unrelated samples t-test. So somewhat a determining factor in what kind of a t-test is appropriate is going to have to do with your research design and the kind of way you collected data from your participants. So when we're doing research that would lend itself towards a t-test for independent samples with two groups, essentially what we are going to be doing is comparing mean levels of some variable of interest between two groups. So we're looking in this case at group differences. Is a group that receives a therapeutic treatment going to have better health outcomes than a control group? Okay, or it could be that we have two levels of our independent variable. So again, if you consider something like treatment group to be the independent variable that has two levels within it, right? Again, you've got a treatment group or a control group. Critically is that we're going to be talking about two distinct groups, two distinct samples of individuals, and we want to see we want to see whether the two groups are different from one another. The t-test is going to additionally allow us to determine whether or not the difference in mean levels between the two groups rises to the level of significance. And again, the kind of t-test that you should use is going to be partially determined by the sorts of experimental design that you used. So we're going to be comparing scores from two different groups, but what we mean by two different groups depends on how those groups were created. So essentially the way this is going to work is, as we've learned, hypothesis testing is about evaluating the likelihood that some effect we have is due to chance. So I showed you this slide during the hypothesis testing lecture, right? This would be the kind of data that would lend itself to a t-test, right? I collect the average score on an exam, and I need to know the mean for group 1, those who didn't go to the review, and the mean for group 2, those who did go. The idea is there is a difference between those two groups, right? We can see that those who went to the review scored a point higher. What the t-test is going to enable us to do is calculate a statistical outcome that tells us the magnitude of this difference. So it's distinct from doing a correlational analysis, right? Think about how this is different. It's about evaluating group differences. Okay, so the extent to which those two groups differ, right, the larger the difference between the groups, the more confident I could be that the difference between them is due to the groups meaningfully being different. That is to say, the review had a meaningful effect. If you are to have a difference that is small, kind of negligible, again, depending on the sample size, it would be the case that just because the groups are a little bit different doesn't mean I have a good degree of confidence that the difference is due to anything besides random sampling error or chance. So if we're living in a research design that would qualify for the independent samples t-test, this is going to hinge on our samples being independent. That is to say, the two groups, the treatment group versus the control group, the people who went to the review versus didn't go to the review, must be completely separate, completely independent. So what this means is that each subject is only in one group or the other, and each individual participant is only going to give you a single score. The subjects, therefore, aren't paired together in any sort of a meaningful way. Again, the participants are only in one group or the other and only giving you a single score. In order to make sure that when you try to evaluate whether or not the groups are meaningfully different because of your independent variable, it's important, if you are assigning people into groups, to randomly assign people into groups. So in the example of the review session, goers doing better than the people who didn't go to the review, one thing that would be important is to make sure that I didn't just allow people to select into the review group and then people select into the not going to the review group. The reason that would limit my ability to make conclusions is because if the group who attended the review ends up having a higher score, I can't necessarily pinpoint my review as the determining factor that made the difference in exam score. It could have been that students who are already more conscientious selected into the review session group. So if you really want to be able to make effective claims, if you're using an independent samples design, whenever appropriate, you're going to want to randomly assign people into one of the two groups. So that would mean that out of, let's say, 50 students, each one has an equal chance of being assigned to the review session versus assigned to the missing the review session. As with other inferential tests, some assumptions about the data should be evaluated and made to be true about the data before the t-test is appropriate. If assumptions are violated, typically it's not the end of the world. You still may be able to use a similar analysis. You just might need to do some corrections to the data, or it might be the case that you would want to choose a different sort of analysis. But critically, if you're doing a independent samples t-test, your dependent outcome needs to be on a quantitative scale, so interval or ratio. Now the grouping, that would be considered a categorical variable, right? Whether you're in a treatment group or a control group, that's a grouping variable, so that's categorical. But the outcome should be measured on a quantitative scale. So for example, if it's a treatment versus a control group, you're assessing health outcomes on a 1 to 7 scale, something like that. Data should be relatively normally distributed in the dependent measure. If your data violates relative normalcy, there are ways that you can correct for that, and there are ways that you can assess to make sure you've achieved normalcy. For our case, we're going to assume that the data we'll be working with is relatively normally distributed. And again, to the extent possible, the groups should truly be independent. So we're going to look at the next t-test lecture about into some more related samples. If you do have samples that are connected to one another meaningfully in some way, let's say you're doing a repeated measures design where each participant is giving you multiple outcome values. Okay, if we want to use an independent samples t-test, we should make sure that our groups are truly independent. Okay, our groups are completely separate. All of our participants are only in one group or the other. Additionally, you want to have the variance in your two groups be relatively similar. So when we say homogeneity of variance, homogeneity means sameness. So we want data in which the variance or spread of the scores is relatively similar in groups 1 and group 2. They don't need to be exactly the same. The level of variance doesn't need to be identical in groups 1 and 2, but it needs to be roughly similar. You wouldn't want the variance to be crazy all over the place in one group, and the second group, every participant was giving you the same dependent variable score. There's a quick and easy way to assess for homogeneity of variance that SPSS builds into your independent samples t-test that I'll show you later. It's called the Levene's test. Essentially, you just want to make sure that you've evaluated your Levene's test and you've cleared the bar of homogeneity of variance. So now let's get into an example. Let's say a researcher wants to know whether using an cognitive imagery strategy affects one's ability to remember a list of words compared with performance when no strategy is used. 20 subjects are randomly assigned to one of the two groups, leaving 10 participants per group. Each group hears a list of 20 words. One group is told to form a mental image of each word, while the other group is told to just repeat each word. Okay, so these two groups, group 1, the imagery group, and the control group, these are meant to be completely separate groups. Participants are only in one or the other. Okay, so this is something you're going to want to keep in mind. This paradigm has both an independent variable and a dependent variable. So the independent variable here, we would conceptualize as strategy or group, or you could call it condition. So that represents a single variable. That variable has two levels within it. Okay, a variable needs to be something that varies to different levels, and in this case, the single variable of grouping has the two levels of imagery versus nothing. Okay, distinct from the independent variable or the grouping factor is the dependent variable. right? So subjects then have to produce an outcome. They need to recall as many words as possible. So this would be your dependent variable, and critical is going to be the number of words recalled. Okay, so the idea is this is a dependent variable that's on a ratio scale, right? People can remember 0 or upwards, so there is an absolute 0 or true 0 within that scale. Okay, so as long as your DV is on a quantitative scale, you're good to go. But again, keep in mind, the independent variable is the grouping variable that has 2 levels. The dependent variable is the quantitative variable, or your outcome. Okay, since the subjects were randomly assigned to 2 groups and the 2 groups were truly independent, your independent sample t-test is going to be appropriate. So the basic approach is going to be to compute the test statistic, the outcome statistical value, which is going to be called your t-value. The magnitude of your t-value is going to tell you the magnitude of the difference between the groups. Larger t's, bigger differences between the groups. Then we need to, as always, evaluate our obtained t-value for significance, and we do that by comparing it to its sampling distribution. This is something we've encountered before. Again, the idea is that we need to evaluate our obtained statistical outcomes against underlying probability distributions that are slightly affected by the sample size or degrees of freedom. So there's a unique underlying probability distribution for a variety of sample sizes, and your t-statistic needs to be evaluated for significance by being compared to its unique underlying null distribution. Okay, so we apply this to our hypothesis testing framework. In this case, the null and research hypothesis is going to reflect the idea that we're interested in group differences. The null hypothesis is going to be that there's no difference between the groups. The alternative hypothesis for a t-test of this sort is always that there is a difference between groups. So this is how you compute your t-statistic for independent samples. Okay, again, whenever I show you guys a formula, I always make sure to mention that if you just look through the notation, nothing here should be overwhelming or novel to you. You've seen all of this before. Everything in here is a notation you're familiar with. Okay, so keep in mind, you've got your x bar that you're familiar with, right? The mean of x. The subscript notation of x bar 1, that's just the mean of group 1. X bar sub 2, that's the mean for group 2. Okay, so the numerator of your t-statistic is just the actual difference between the means of your 2 groups. But you don't just want to compute your t-statistic based on the absolute difference. What needs to go into the t equation as well is going to take into account the sample size in each of your groups. So you see n sub 1 several places within this equation. That just means the number of people who are in group 1. Okay, n sub 2, likewise, that's the number of people in group 2, right? So if you look back to when I stated the example, there are 10 people in each group. So you're just going to plug in 10 wherever appropriate. Okay, S sub 1 squared. If you remember back to when we learned about descriptive statistics, that's your variance for group 1. Okay, S sub 1 squared. Recall that variance is S squared because your standard deviation is just S, because the standard deviation is the square root of the variance. So S squared is your variance. Okay, again, the t-test is not just going to be derived by the absolute difference between the means of your 2 groups. The sample size in both groups, as well as the variance in both groups, is also taken into account when we compute our t-statistic. So S sub 1 squared, that's the variance just for group 1. Likewise, S sub 2 squared, the variance for group 2. Okay, so if you remember back to the computation of variance, you know how to do that. Typically for a t-test calculation, I would give you the variance since a fair amount of backing work goes into computing the variance. Most of the time, I'm going to provide you with the variance here, and you're not going to need to calculate it separately. You're just going to need to know how it fits into this equation. So again, make sure that when you see a formula like this, you understand that it has the complete list of steps that you will need to complete in order to compute your t-statistic. Okay, again, critically, make sure that you're not confusing that s squared as being a standard deviation. It is, in fact, the variance. Okay, it needs to be the variance or else your outcomes are going to be all screwy. Okay, so this would be what your data looks like, right? You had your 10 individuals in your imagery condition who all remembered a certain number of words. So the number listed is their outcome. And then likewise for the no imagery group, they each gave you a single value representing the number of words recalled. Okay, so you're going to need the mean and the variance for your imagery group and the mean and the variance for your no imagery group. Okay, so then you just need to plug the pieces of information into the appropriate spot within the equation, and then from there it's just simplifying it down until you get your single obtained t value. Okay, so the t in this case is positive 2.8. Okay, there is no numerical range within which your t is going to be. It's not like the Pearsons are in that way. But larger absolute values of a t statistic indicates greater difference between the groups. So it is similar to the property of the R that the distance from zero of the t tells you about the magnitude of the difference. Now your t statistic can be positive or negative, but ultimately that's going to be completely arbitrary. Since there's only two groups, whichever group is defined as 1 or 2 is completely arbitrary, right? You could completely flip the notation and call the no imagery group group 1 and the imagery group group 2, completely flipping the notation of the categorical variable. Your t statistic absolute value would be the same. It would be flipped to negative. Okay, so the sign of the t statistic, positive or negative, doesn't really tell you much. It just tells you which of your variables was or which level of your independent variable was coded as first versus second. It's really just the absolute value of the t statistic that you care about. So as with our other inferential tests, you then need to evaluate your obtained t statistic for significance by using a critical t table. Using our classic decision rule of p equals 0.05, two-tailed, degrees of freedom in this case is going to be the degrees of freedom for group 1 plus the degrees of freedom for group 2. So essentially it's the n for both groups added together minus 2. Okay, so in this case, the critical t for data that looks like this with this sample size for an alpha value of 0.05 is going to be 2.101. The application of the decision rule is, again, does my obtained t statistic exceed the critical t cutoff? Again, for this, you can use the absolute value of your obtained t because the sign of the t ultimately doesn't really have much meaning. It's just about whether or not your obtained t is farther away from zero than the critical t. So in this case, we have cleared the critical t value, and as such, we can reject the null hypothesis of the groups being the same. And thus, we can conclude that memory strategy does appear to affect performance. Okay, the people who used the imagery strategy had a higher number of words that they were able to recall. Here's that critical t table I just mentioned. And again, as we've seen, the table is going to be determined, or the way you find the critical t is going to be by using the column indicating the degrees of freedom. So you need to find the appropriate degrees of freedom. You can see that you've got degrees of freedom going all the way up to 30, and then from there it just goes basically in 20s, because once you get past a certain n, the critical t value doesn't change very much because the underlying probability distribution doesn't look very different with the degrees of freedom of 80 versus 100. But before you get to about n of 30, it is a lot more impactful. You then also need to figure out which critical probability cutoff you are trying to achieve. And when you find the intersection of the degrees of freedom row and the critical probability value column, Okay, it's going to depend on whether or not you used a one-tailed or a two-tailed approach. Okay, but in this case, err on the side of using a two-tailed approach, but either one of those would be appropriate as your critical T value. But in this case, the two-tailed approach of critical T 2.101 gets you to significance anyways. It wouldn't have mattered. So now I'll show you how you would do this same analysis in SPSS. So critically is that, again, this is a design that actually has two variables at play here. So one is your categorical grouping variable. You need to make sure to distinguish which one of your participants were in the first group versus which one were in the second group. So you're going to need to create a variable in SPSS where you create the coding values. So you basically create a value and you label it with your categorical label. So I've decided to label group 1 as the imagery group and the no imagery group as group 2. So I need to add those labels in my variable view of SPSS. You also need to create your recall variable so you can enter in the information for your dependent variable. So I've coded my first 10 participants as group 1 and entered their recall scores, and I've coded the next 10 participants as being in group 2, and I've entered their recall scores. So your data in SPSS would need to look like this. You need a variable that distinguishes which group your individuals are in, as well as a variable for the dependent variable. So then from there, this is how you conduct your independent samples t-test. You go to Analyze, drop down to Compare Means, and choose the Independent Samples t-test. Again, there's different kinds of t-tests. Right now we're doing the independent samples version. Okay, so you need to define your groups. Basically, you're just saying which group you're calling group 1 and which group you're calling group 2. You could flip this around so that the t-test was going to call group 1 your group 2. Again, it just flips the order of the values that are in the numerator of the t-test equation. So it really doesn't matter. Flipping these around is going to flip the sign of your t, but like I mentioned, the sign of your t value doesn't actually really matter. But you do need to go in and click that Define Groups button, enter groups 1 and 2, and hit Continue. Then from there you hit OK, and this is the output for your independent samples t-test. So you can see at the top that you have that descriptive information. You've got your N for your two groups, the mean in your two groups. You can see quite clearly that the imagery group has a higher level of recall just based on the means. Standard deviation, which is related to the variance, looks quite similar. Then there at the bottom, we have the information that relates to your independent samples t-test, so your t statistic. That value there, under the t column in that first row, is going to be your obtained t statistic. You move over to the column labeled significance two-tailed, and you see that the p-value listed is less than 0.05 at 0.011. Hence, our t is flagged as significant. Now, like I mentioned, one of the assumptions of the independent samples t-test is that the variance in your two groups is roughly proportional. Doesn't need to be exactly the same, but it needs to be pretty similar. Just eyeballing the standard deviation, it would appear that likely the variance in the two groups is not wildly different. It appears just by a rough eyeballing that it is quite similar. The Levene's test for equality of variances actually assesses whether or not the variance between the groups is significantly different. Now here's an interesting case that we haven't seen before. The Levene's test, we are actually hoping for non-significance. So notice that the F value, which is the statistic associated with your Levene's test, is quite small, and the significance is much greater than p equals 0.05. So it's not significant, it's nowhere near close. That's actually a good thing. This is a rare case where we are hoping for non-significance. When your Levene's test is significant, that means that your two groups have unequal amounts of variance, which you don't like. It limits the effectiveness and the accuracy of your t statistic. So the fact that it is not significant there in the Levene's test, that's good. That means that we can keep our interpretation of this analysis with all of the values in that top row labeled equal variances assumed. Look all the way over to the left where it says equal variances assumed, and all of the values in that row have been what we're looking at. The only reason we can use that row is because Levene's was not significant. If the Levene's had been significant, we would have had to move our attention lower. Okay, so this is what the Levene's test accomplishes. It assesses whether the variance is roughly equal in your two groups. SPSS is automatically going to tack this onto your independent samples t-test, so you don't need to choose a specific option in order to have this be associated with your t-test. Okay, so what's interesting about the t-test is, again, the null hypothesis is that there's no difference between groups. So this is the rare case where that's actually what you're hoping to find. Okay, the alternative hypothesis is that there is a difference. And again, recall that that's what you don't want. So in this case, it's that you are hoping that your Levene's test is not significant, because if it is significant, that's a bad thing. Okay, so this is a rare case where you don't want a significant result. You should still look at the Levene's test in your analysis. Just make sure that it's not significant. If it's not significant, you're good to go. Okay, so again, there's that second row of equal variances not assumed. In this case, our values in the equal variances assumed and not assumed is the same, so it doesn't really make a difference. At times, the equal variances not assumed row is going to have values that are slightly different, that adjusts for the discrepancy in variance. Okay, so if the equal variance assumption was to be violated, typically you would see a much smaller t-value emerge in that equal variance is not assumed t statistic. But for our case, in this particular example, we cleared the bar, or rather we didn't clear the bar for significance. Levene's test was not significant. That's a good thing. Okay, so now I'm just going to show you a practice problem that you can work on in your own time. I know a lot of people are interested in this classic question of whether or not video games make people more aggressive. So in this hypothetical, let's say we randomly assigned a group of individuals to spend some time either playing a violent video game, Mortal Kombat, and the control group is still going to play a video game, but a non-violent one, so let's just say Tetris. Let's say that after the video game prime, or the video game experience, participants were then told they'd have the opportunity to administer unpleasant white noise blasts to another Confederate participant, and the blast could last however many seconds they wanted. So this is a classic aggression-dependent variable that's often used in laboratory settings, because we do consider administering an unpleasant, shocking blast of white noise to someone to be something that denotes aggression, but it's not so bad that we are unable to get away with doing it in a laboratory. So the following data is going to depict the length of noise blast chosen by participants. So what you're going to do is compute your independent samples t-test, assess for significance, summarize your results in 1 to 2 sentences. Okay, so this is your t equation. This is the data. Here's your descriptive statistics. You can use the standard deviation to create your variance. Again, keep in mind that standard deviation and variance are not the same thing, but this is everything you need to complete this equation, to compute this t statistic. Okay, so if you'd like to practice this question now, just pause this video, take about 10 minutes to work on this computation, and then return when you're ready to look through the answers. Okay, so let's resume and go through the completion of this computation. Okay, so you've got your Mortal Kombat group with their mean and standard deviation. Again, keep in mind that if you have the standard deviation, you just need to square that value to get your variance. Okay, so you've got the information for your Mortal Kombat group, and likewise the information for your Tetris group. So then from there, you can create all the pieces you need to complete this t computation. So you've got your standard deviation for both groups, which you have to turn into your variance, and you've got your mean for both groups. You also need to know the number of participants in each group. In this case, there were 9 in the Tetris group, 9 in the Mortal Kombat group. So then from there, this is how you would fill in your pre-solved t equation. Then from there, it's about solving it down. Okay. and you end up with a t of negative 0.39. Again, the sign of the t-statistic, if you had switched groups 1 for group 2 so that Tetris was group 1 and Mortal Kombat was group 2, if you have the same absolute value for your t-statistic, you likely did nothing wrong. Okay, again, the sign of the t-statistic is just going to be a virtue of the fact that one of the groups is coded as group 1 and another is coded as group 2. You could flip them around and it wouldn't make a difference. The absolute value of your t-statistic should remain unchanged. Okay, so again, using your critical t table, you'll first direct your attention towards the row with the appropriate degrees of freedom. Recall that the degrees of freedom for your independent samples t-test is going to be the n of group 1 plus the n of group 2, so your overall n minus 2. And then you're going to find the column representing your critical probability cutoff, whether you're going one-tailed or two-tailed. Okay, so one of those is going to be your critical t cutoff. Again, I'll show you the work in SPSS. Again, note that in the variable view, I've created a categorical variable for the gaming condition and coded the individuals who were in the Mortal Kombat group as all receiving a 1 versus those in the Tetris group are going to receive a 2, as well as a quantitative variable for the amount of time spent delivering noise blasts. So again, notice that in this case, I've got a variable just IDing my participants as 1 through 18. I like to do that just to keep my participant ordering straight. I've got the gaming variable denoting that my first 9 participants were in group 1 and my second group was labeled as group 2. And then I have the timing variable indicating the amount of time spent delivering a burst of white noise. Same as before, you go into the compare means independent samples t-test. You need to define your groups, and then from there, your analysis would look like this. Again, you've got your descriptives up top, again, your mean and standard deviation for both. When you go down into the actual t computations, we can see that the Levene's test is not significant, so that's a good thing. You've got your t statistic, that negative 0.392, so our work was correct. Okay, and then you've got your significance value. This actually does not rise to the level of significance. A p of 0.7 clearly is nowhere near the p equals 0.05 bar for significance. So the conclusion you would make is that there is no difference between the violent and the non-violent video games in terms of amount of aggression in this particular research paradigm. Now, I've linked here an online t-test calculator. If you ever have trouble accessing SPSS using the VPN, you can use any number of online t-test calculators to check your work like this. Again, it's just going to have it's going to have the ability to create your 2 groups and then to create your dependent variable outcome values in your participants in group 1 versus group 2. Okay? So if we were in class, we would be having a brief discussion where you guys would get into groups and try and find an article that includes an independent samples t-test. It's actually a quite widely used analysis. It's pretty frequently useful. So it shouldn't actually be that hard. I would recommend doing this on your own time or getting on a Zoom call or a Skype or Google Hangout with someone else in the class to see if you can find some good results on PsycInfo for an article that includes an independent samples t-test. As always, I recommend doing this because it not only helps keep your article finding skills sharp, reading any real article publication that uses a particular analysis is a great way to make sure that you understand what the analysis is really good for, and it helps affirm your understanding of conceptually what the analysis is good for. And lastly, it also gives you a sense for the statistical write-up. So for example, when you have an independent samples t-test, the write-up will typically include your t-value, your degrees of freedom, t-statistic, and the p-value. You'll typically also see the actual descriptive means in your 2 groups. So it's good to get a sense of how the statistical write-up actually looks in a real publication. So things to note if you find an article that uses an independent samples t-test, make sure you can define which is the independent variable, that is to say the grouping variable, and that you can distinguish the dependent variable. Again, make sure that you're not conflating the two. This is an analysis in which the design necessarily has 2 separate variables, an IV, an independent variable, and a DV. So if you find an article, just find the results of the t-test and take note of what's included and how the t-test was analyzed. So that'll do it for me for today. I'll talk to you guys soon. I hope you're staying healthy and safe and sane. And I'll talk to you soon. Bye.